In this video, you're going to learn all about ergonomics, how to set up your desk, what makes a comfortable chair. No, of course, we're not going to do that. We're going to talk about JVM ergonomics. Ergonomics in the JVM as one of its main benefits of writing applications in Java. If you're used to running Java applications where that JVM gets an entire physical machine or virtual machine, then the main reason that you don't have to give it too much configuration is ergonomics. We're about to deep dive into containers and understand how running Java in containers can be quite complicated. And one of the reasons it's complicated is because of ergonomics. That said, things have improved drastically in the latest versions of Java. So if it's not desk setup, what are ergonomics? JVM ergonomics automatically configure the JVM based on the resources the machine has that it's running on, so its memory and CPU. This prevents you from having to do so until you need to fine-tune something like garbage collection. So the first is memory. There's all sorts of different types of memory in the JVM, but the primary one is heap. And JVM ergonomics look at the amount of RAM on the machine and then set the initial and the max. So for instance, if you have 16 gigabytes of RAM on your laptop and you start a JVM, the max heap size it'll be given is 4 gigabytes. It isn't just some hard-coded value. If you've not looked into this before, you might be wondering, why is this so low? And that's because heap is just one part of JVM memory. Heap is just where your objects are allocated. There's also thread stacks. So for every thread you create, the JVM allocates a megabyte for the thread stack. There's off-heap memory allocated by byte buffers. You might not do that in your application, but chances are there's a library on your class path that's doing it. We'll use a tool in a later video during the container deep dive on memory called native memory tracking. And then we'll actually be able to see for the JVM which parts of memory are using up the most. We'll also demo a container being killed for using too much memory, even when we don't allocate a single thing on the heap. The next ergonomic feature is for the internal thread pools of the JVM. So Java has a whole host of parallel and concurrent garbage collectors. When we say parallel, it means they can run next to your application. They're at the same time. Even though a lot of garbage collectors in Java do stop your application, they do a huge amount of stuff in parallel. And when we say concurrent collectors, it means that the collector itself spawns multiple threads to do its work. And it bases that number of threads based on the number of cores on the machine. So if you deploy a Java application to a machine with 128 cores, you'll get a very different number of garbage collection threads than say on your laptop or on say a 1-core or 2-core virtual machine. The other is the just-in-time compiler. As your Java application warms up and it starts to compile code to native code, it does that with a number of threads, and that's based off the number of cores. Next is the fork join pool. So this is a work stealing executor, and maybe you don't use the fork join pool directly, but there's one which is set up by default in the JVM, and it will run things like if you were to use Java 8 streams, the parallel streams, and the number of threads it's allowed to create is again based off the number of cores. The JVM has really good behavior for changing based on the machine it's running on, and there's lots of user level libraries which have then taken this and done it as well. So the number of cores available on a machine is accessible when you're in your Java program. You can call runtime.availableProcessors and it'll return how many cores. I'm a maintainer of a library called Akka, and we use this to dictate how big our thread pools are going to be. And also the very popular library Netty does it as well. And you might not be a direct user of Akka or Netty, but chances are, again, you've got something on your class path which uses these internally, because often things like HTTP clients and database drivers will use a library like Akka or Netty under the covers. So what I want you to take away from this video is ergonomics are important. They've saved you a huge amount of time in the past, and they have the ability to save you a huge amount of time in the future. You are using them even if you don't think you are, either via the garbage collector, the JIT or a user level library, which is maybe a transitive dependency. And you might be asking yourself, what does this have to do with containers? Well, until very recently, JVM Ergonomics did not take containers into account. It would base all of these decisions based on the number of cores on the machine, not the CPU resources given to a container. So you would have your container running on your laptop, which might have 8 cores, and it might work fine, even if you were to only give it 2 cores in the container, because these are quite similar. But server grade machines have a lot of cores. It could be 64 or 128 or 256. And suddenly, if you're running a container that you think you've given 1 CPU to or 2 CPUs, and then it's making all these decisions off 128 cores or 256 cores, worst case scenario, your application will be slow, but often it would just crash in production. All of this has been improved a lot, and we're going to go through that in detail. But particularly for CPU, there's a lot of gotchas left, and that's what we're going to cover in the deep dive. But the caveat and thing I want you to take away from this is make sure you're on the latest JRE. Java 11 has much better support for containers than earlier versions. Many of those features were backported into Java, first in Java Update 131 and then in Java Update 191. But it's very easy to accidentally or be hit by a change of behavior, even in a Java patch version. So that was a brief introduction to JVM Ergonomics. And now it's finally time to deep dive into containers. We're going to look at how CPU works and all of the pitfalls that you can have running Java inside containers.